Hello everybody, welcome to Algebra 1 CST release question number 64. It says 4 steps to derive the quadratic formula are shown below. And you've got 1, 2, 3, and 4. What is the correct order for these steps? So apparently these are not in the correct order, but we're supposed to either start with 1 or 2. So let's see which one of those makes more sense to start with. It looks like this one is less complicated, less changed than this one. So I would say let's start here. This is the first thing. So I'm going to write that off to the side over here. X squared plus bx over a equals negative c over a. And so what would come next? What could we do? Well, we just saw in number 63 that we can add this b over 2a squared by completing the square. That's what we're doing. We're adding that to both sides. So this is really how the quadratic formula is proven, or where it comes from. So what can we do? We can add that to both sides. Step 2 would be to have this bx over a plus b over 2a squared. We're adding that to both sides of the equation. B over 2a squared over here as well. So this is still, the red part was everything that I saw up here is just carried down here, and then I'm adding this to both sides of the equation, completing the square by doing that. And so this was step 1. Let me put that on this side instead. This is step 1. And then the second step would actually be to do this. So step 2, step 1. It looks like choice A has to be my choice, because I know that 2 wasn't the right step to start. That was more complex than we could get to yet. We're actually getting there. Step I don't know if you can hear the kids crying. Again, I'm at a friend's house, and we're just hanging out today, but poor little guy is in his terrible 2 phase. Anyways, back to the question. Back to what we got here. We've got x plus, and then it's always going to be this part just by itself. It's that squared, but if we had x plus b over 2a and squared the whole thing, and over here, this is over 2a, so if I multiply this part by 2 on the top and the bottom, I would have a common denominator right there. Actually, I would have to multiply that through. I'm sorry. So if I multiplied, I'll get to that step in a second. I'm getting there, so hold on. So we've got this part squared. If I FOIL this back out, I would have x squared. I would have b over 2a times x. I would have that twice, b over 2a times x twice. And b over 2a times x plus b over 2a times x. This would be the outside and the inside parts of FOIL. If I FOIL this back out, think of this as 2 binomials times each other. You combine these things together, you'd have 2 b's and then a common denominator of 2a on the top, which would be the same thing as just b over a times x. So that gets us back to what we started with up here. So we know that this whole thing can be simplified like this. Completing the square, again, is supposed to do just that. Make it so that you can have something times itself, something squared. Over here, let's think of this a little more broken apart or split apart. I was trying to do a little bit too much at once earlier there before. So b over 2a squared, that would be b squared on the top, and then 2a times itself on the bottom would be 4a squared on the bottom. To combine these two things together, we would need to get a common denominator. That's not showing up very well. Let's try yellow instead. That's better. So I could multiply by 4a on the top and the bottom for this particular fraction. That would give me 4a squared on the bottom over here. And so I would have minus 4 times a times c over 4a squared, or negative 4ac over 4a squared, and then b squared over 4a squared over here. Combine those two things together, and you have a fraction that looks like, oh, that looks familiar if you know your quadratic formula at least. B squared minus 4ac all over, and then this is 4a squared at least at this point. So we have what you see here in step 2. B squared minus 4ac all over 4a squared. So that's our third step. which jives with what we have here. We thought it would be 1 and then 4 and then 2, and now it should be step 3. So it looks like, how can we do that from here? It looks like we can take the square root of both sides here and here. The square root and the square would cancel right there, leaving me with x plus b over 2a on this side equal to, we have the square root of b squared minus 4ac. On the top, the square root of 4a squared is just 2a, however. And then subtracting b over 2a from both sides, b over 2a from both sides, get that to cancel, you would have x is equal to, we would have negative b over 2a plus the square root of b squared minus 4ac over 2a. And if I just flip-flop this part with this part, I would have exactly what I see here, the square roots. And I can think of this as plus or minus. I should actually be or have been doing that all along. It looks like I didn't actually need to take the square root of 4a squared either. I'm kind of trying to get to eventually what you would see with the quadratic formula that we all hopefully know and love. And so, yes, this would be the same thing as this. Again, I've taken the square root of 4a squared over here, but they didn't right here. But without that, that would be exactly the same thing as what you see here. I just want to finish this up, though, because if we do this one more step, we've proven the quadratic formula, why it actually works. And so we have x equals, and we can have here negative b, because we have the same denominator here now, 2a, so negative b plus or minus the square root of b squared minus 4ac all over 2a. Beautiful. There is the quadratic formula, but these were the correct steps. The Roman numeral 1 came first, then Roman numeral 4, and then 2, and then 3. And so the correct choice for number 64 is choice A.